Shall we start now? Now, first thing, in motion under gravity, we have saw one thing. And whenever object is being projected in the upward direction, like this, consider from here, if the object is projected in the upward direction, this point, for example, over here, there is a point A. Okay. So when we are going in the upward direction, we met a point A at time t is equals to 1. So, okay. So t1 we met over here. While returning back, we also find this t2 now. Yes or no? So can I say that in vertical motion, a single point can have what? 2 times. Yes or no? Similarly, in when the object is moving along the horizontal, if the object is considered this as your point A and this point is being at t1 from the origin, if the object's velocity at this point becomes 0, definitely object will returning back now. Yes or no? While returning back, can I also say that it will be meeting a point that is what? A again at a time t2? Yes or no? So similarly, can I also say that in projectile, in what? Projectile, same height can have 2 points, 2 times. That means, for example, consider here from a height, let this height is h. Similarly, over here also there may be a height h. Can I say that this point, let this point is A and this point is B, can I say that at point A, time will be t1, at point 2, can I say time will be t2? Can I say that? So whenever the question is given, find out the time period, if the object is at a height, certain height h. So we will be having 2 values. And how we are deriving our time? By Sx or Sy? We are always deriving our time by using Sy is equals to Uyt plus of half of Ayt square. Yes or no? Can I say that I will be getting a quadratic equation where I am having 2 times, that is time 1 and time 2? Are yes or no? Are you got my point? Similarly, now let us try to understand this by one example. Okay, write down a question. Consider a object is being projected. With 30 meter per second, cancel that, 25 meter per second, at an angle of 30 degree, find the time period, when the object reaches 5 meter above the ground. So in this question, given data is initial velocity is given, angle of projection is given, and height above the ground is also given, and they are asking you to calculate what? Time. So if I draw the projectile, then can I represent this projectile like this? Okay, it is been initially incident with what? U is equals to how much? 25 meter per second at an angle of how much? 30 degree. Then this is your y-axis, this is your x-axis. Consider this is being projected from 0, 0, that is your origin. What we are discussing, ground to ground now. So let us try to understand. So in this direction, can I write this as ux, and ux is nothing but u cos of theta. And what is the theta? 30 degree, u is given 25. Then can I write ux is nothing but 25 cos 30 is how much? √3/2. This is the velocity along what? X-axis. Similarly, we can also define what? Velocity along y-axis by using uy is nothing but u sine of theta, and u is what? Again 25 sine of 30 degree, that is 1/2. That means 25/2 meter per second is your uy velocity. Yes or no? Now, they are asking you to calculate what? Time. Generally, we calculate our time by using what? Sy equation. Na? So Sy is equals to Uyt plus of half of Ayt square. Okay. Now, height is given. At what height they are asking to calculate? At 5 meter. Now consider over here is 5 meter above the ground. This h is 5 meter. Similarly, I will be having the same height again here while descending. Okay, so 5 meter one time during ascending and 5 meter again during descending. So let's say this one is your T1 and this one is your T2. Okay, we can calculate the coordinate also. Yes or no? Already y is given, y coordinate is given 5. Over here x comma 5, over here x2 comma 5. Yes or no? We can also find the displacement between, consider this point as A and this point as your B. Find out the displacement, we can find the displacement. Find out the velocity, we can find out the velocity. What is the velocity here and what is the velocity here? Average velocity direction will be in this direction. Na? So can I say this is your V average? And at this point, can I say this is your V instantaneous? Similarly, at this point, this is the direction of V instantaneous. Yes or no? Okay, now let us come back to our topic. We are calculating what? Time. So height is given how much? 5 meters. So substituting here 5, which is equals to uy is equals to nothing but 25 upon 2. Time we don't know. Plus of, sorry, minus of, can I write directly 5t square? Yes or no? Can I also substitute over here? This 10 is equals to 25t minus of this 10t square, and reshuffling that, then the equation becomes 10t square minus of 25t plus of 10, which is equals to what? 0. If you get a factorization, factorize that, and if you don't get the factorization, substitute in what? Quadratic equation. So let's say we can cancel this by 5. So this becomes 2t square minus of 5t plus of 2, which is equals to 0. 2 2s are 4. 4 1s are 4. Yes, it gets factorized. So 2t square minus of 4t minus of 1t plus of 2, which is equals to what? 0. Over here, can I take 2t common? Left out is what? T minus of 2 minus 1 taken as common. T minus of 2, which is equals to 0. Then 2t minus of 1 is equals to 0. T is equals to, that means time 1 becomes half seconds and T2 becomes 2 seconds. Are yes or no? This is how the question will be done. Are you got my point? Easy questions. Only thing, mathematical part get increased if the factorization is not getting happening. Okay, all you need to substitute what? Quadratic equation. Okay, note down. Let us recall what we have learned yesterday. Shall? Okay. Now consider range. What is our range? Range formula. So can I write this as nothing but 2u sine theta into u cos theta upon g, or this also be written as, yesterday I told you that this can be written as u square sine 2 theta upon g, or this can also be written as 2 times of ux uy upon g. Yes or no? And yesterday we already discussed that when the Rmax, that means range become maximum at 45 degree. Na? That means, can I say that by using that we have found that range become maximum when theta is what? 45 degree. If theta is what? 45 degree, then range become maximum. If I substitute in that, then can I write u square upon g? Yes or no? Okay, sine 2 theta is equals to 1 and theta is equals to 45 degree. Substituting over here, we get what? Range is equals to u square upon g. Yes or no? For example, with whatever the value I substituted, okay, let's say initial velocity is 100, 200, 45, 30, whatever you want to consider, you can consider. If I substitute the value, initial velocity is u meter per second. If I projected that angle, that is what? By 45 degrees. Okay, this is your x, this is your y. If I project a particle, object, body at 45 degree with whatever the speed is, okay, with whatever the velocity is, if I incident that, sorry, not incident, if I project that by 45 degree, then what we get is always this object will be having this parabolic path now. If this object is having a parabolic path, then can I say that this is your range and this range becomes maximum? Yes or no? This range becomes maximum, and we will be getting some height, that is your, this is your Hmax. Are yes or no? Then what we get by using this 45 degree with any velocity, you will be getting what? Range is always equals to 4 times the Hmax. Okay, and this is only applicable. This is only applicable at theta is equals to 45 degree. Okay, yesterday we done one question, something 100 root 2. Yes, no? What is the height over there? 500. And what is the range over there? 2000. And what is the theta we have taken? 45 degree. I written 100 root 2. Why? Because I know that whenever to cancel root 2, I will be using what? 45 degree. So yesterday's question, if you see carefully, the range is what? 500 meter. Sorry, the Hmax is what? 500 meter, and the range becomes what? 2000 meters. This is only applicable if this theta is 45 degree. If theta is 45 degree, if height is 1 meter, then your range will be 4 meters. I got my point? Okay, right on. Okay, shall I? Now listen to me. Consider I projected one object exactly in the vertical direction. That means what is theta here? Can I say theta is nothing but 90 degree? If theta is 90 degree and I projected this object with u meter per second, initial velocity is what? U. It will be going to Hmax somewhere here. Then it will reach to what? Hmax, and here velocity becomes what? 0. We already know this. In projectile, for example, I am again projecting this object with some initial velocity. This will be your height, and this is your what? Theta. Are yes or no? In projectile, what we write for the Hmax? We generally write what equation? That is what? Hmax is nothing but u square upon 2g, and that is nothing but with sine square theta. Yes or no? Similarly, if I want to write the range equation, then I will be writing range is nothing but u square sine 2 theta upon g. These are the equation. Are yes or no? Now I want the maximum height. If I need maximum height, do I need to project that with angle or with 90 degree? Yes, absolutely with what? 90 degree. Then if I substitute that 90 degree, then sine 90 is what? 1. Then Hmax equation for maximum height, then Hmax becomes what? U square upon 2g. Yes or no? In this case, if I substitute with the theta, that is what? 90 degree, I will be getting Hmax is equals to u square upon 2g. Similarly, I need more range. That means I need maximum range. Then definitely I will be projecting that object by what? 45 degree. Yes or no? If I project with 45 degree, then can I write the equation of range? Over here, theta is what? 90 degree. Okay, I need what? Maximum range. For maximum range, then same velocity. Velocity is same. I am throwing with u meter per second in the vertical direction. Again, over here also I am projecting with the same velocity, but with what? Angle. Why? Because I need over here range and I need over here what? Height. So if I keep the theta same, then can I write u square upon g? Are yes or no? So for maximum height, I will be using this, and for maximum range, I will be using this. If consider a man projected an object with u meter per second in the upward direction, that is using theta is equals to 90 degree, he will be getting this height. Yes or no? If the same man is projecting the object with angle theta is equals to what? Over here the theta becomes 45 degree now. Theta becomes what? 45 degree here. If theta is 45 degree, then I will be getting what? Maximum range. Now the question arises, if the question is being framed such a way that if a person is throwing an object with 10 meter per second in the upward direction, it will reach to certain height. It will reach to what? Certain height. If the same person uses the same velocity, how long he can throw? I got my question. A person throws an object in the upward direction with u meter per second, and he also throws the same object with same initial velocity but with what angle, that is 45 degree, how long he can throw. Yes, okay, then what to do? Can I equate this? R is what? U square upon G. If I am saying these two equation, comparing equation, consider this as your equation 1 and consider this as equation 2. Comparing equation 1 and 2, then can I write Hmax is nothing but 1 upon 2, that is your range. Over here, can I write this range is nothing but maximum range. So Hmax is equals to half of the R range. Or can I also say that Rmax is equals to 2 times of Hmax. Over here, what is the condition? U should be same. Over here, U should be same in what? Vertical direction and with what? Projection. I got my point. Over here, theta in the for a maximum height 90 and for maximum range theta will be 45 degree. Okay, right down. Okay, shall I now? Now listen to me. Moving further ahead in the range, if I project an object with 45 degree, whatever the velocity is, if I project the object with what? 45 meter per second, then what I be getting? Maximum range. And if I project the object exactly in this direction, that means over here the theta will be 90 degree, then I will be getting what? Hmax maximum. Are yes or no? Okay. Now the question is, if I project with 0 degree, if I project with what? 0 degree, what is our formula? U square sine 2 theta upon G. Are yes or no? Then 2 theta is equals to 0. 2 theta is equals to what? 0. 0 into anything becomes 0. That means if I project with 0 degree, I will be getting what? Minimum range. So can I say that from 0 degree to 45 degree, from 0 degree to what? 45 degree, can I say that range is increasing? Range is what? Increasing. And from 45 to this 90 degree, from 45 to 90 degree, can I say that range is decreasing? Yes or no? Okay. Similarly, if I want to compare with what? Height. From 90 degree to 0 degree, height is increasing or decreasing? Yes, height is decreasing. So from 90 degree to what? 0 degree, Hmax is what? Decreasing. If you need more and more Hmax, then you need to project with more and more angle. I got my point. Now the question arises is, if there are two more bodies, one body is projected, consider with an angle of let's say 40 degree, not 40 degree, 41 degree, and one more object is projected from the same position, that is 0, 0, again from projecting from 0, 0 with same velocity. This is also having u meter per second and this is also having u meter per second. Over here, now the velocity angle it is making is for this one angle is consider 48 degrees. 45, 48, difference 4, 49, 50 pakad lo. 50 degree. So this one is projected with what? A is projected with 50 degree, B is projected with what? 45 degree, and C is projected with what? 41 degree. Three objects. Who will be having maximum range? Definitely 45 degree. Yes or no? B will be having what? Maximum range. If I remove this object and ask you, who will be moving more in terms of range between A and C? A and C. So just by seeing that we can find the answer. How? Let us say 45 degree is our standard angle, na? for maximum range. So at 45 degree, range becomes what? Maximum. Okay, now 41 and 45. The next angle is what? 41 degree. If I subtract 41 from 45, then I will be getting what? 4 degree. Yes or no? Similarly, if I subtract 50 from 45, then what is the difference between these two? 5 degrees. Are yes or no? So over here the difference is 5 degree. Over here the difference is what? 4 degree. Then who is closer to 45 degree? That means 4 degree or 5 degree? 4 degree. If 4 degree is closer to what? 45 degree, then this point C will be having what? Maximum range. Have you got my point? So whenever two objects is being projected with an angle theta, who is closer to 45 degree? That object will be having more range compared to the other. Please explain yourself. Okay, shall I? I will explain your doubt, don't worry. Consider again, one object is being projected with an angle 39 degree. Okay, and one more object is being projected with an angle, this is what, let's say 65 degree. One angle is projected with what? One object is projected with 65 degree, other object is being projected with what? 39 degree. What is our standard angle for maximum range? 45 degree. 65 minus of 45. What is the difference between these two? Can I say 20 degrees? Or yes or no? Similarly, 45 degree and 39 degree. What is the difference between these two? Can I say 6? Who is closer? 45 to 45. This 39 is closer or this 65 is closer. What is the difference? Over here the difference is 20. What is the difference over here is 6. So who is having the minimum difference? 6. That means body A and this body B, then body A will be having maximum range. I got my point? Simple. Okay, don't confuse yourself. Now let us find one more thing. Consider this is your standard angle 45 degree. Okay, for maximum range. So over here range is what? Maximum. Now if I project one more object here in this direction, consider this angle is given 40 degree. Okay, and one more object is being projected with an angle over here. This angle is given, let's say 50 degree. One is projected with what? 40 degree. One with projected with what? 50 degree. And standard angle is what? 45. That if I compare these two, 50 minus of 45, I will be getting 5. Yes or no? Similarly, if I compare between 45 and 40, then again I will be getting a difference of 5. Yes, they will have the same range, but now can I also say that? If this is theta, if 40 is theta, then can I also write this 50 as 90 minus of theta? सोच के देखो, this can be written as 90 degree minus of theta and this can be written as theta. Are they complementary angles? Yes. So whenever you will be getting theta and 90 minus of theta, if this object is being projected like this, the other object will be projected in this direction with what? 90 minus of theta. Then can I say that this one will be going like this? Are yes or no? Why? Because both will be having what? Same range, na? So from origin to point A, this one will take a time period of T2 and this one will take a time period of T1. But one thing is common. If U is equals to same, if U is what? Same, this one is what? U1 and this one is what? U2. Okay, two objects are being projected with what? Velocities U1 and U2. Or you can say U1 and U2 both are equal. So U1 is equals to U2 should be same, equal. Are yes or no? Okay, but This one is being projected with what? Theta, and this one is being projected with what? 90 degree minus of theta. Then they will have a common range. So range will be same. So can I say that if u1 is equals to u2 and theta and this other object is being projected with what? 90 degree minus of theta and 90 degree of minus of theta, then they will be having same range. They will be having what? Same range, but their time is different. There will be having a times are not equal. Okay, then second thing, can I also say that their Hmax are also not equal? I got my point. So Hmax of 1, this is the Hmax of 2 will not be equal. So whenever theta and 90 minus of theta, that is complementary angle, if they are being projected with what? Same velocity, both will be having what? Same range. Both will be having same range, but the time of flight and their Hmax are not equal. I got my point? Right on. Okay, shall I? In that second bit, now listen to me. Consider one object is being projected with u1 velocity, and let's say this is your height, and consider like this. So this is your x, this is your y, and this is the Hmax of this flight. Okay, and this one is being incident with theta, and initial velocity is u1. Initial velocity is what? u1. Similarly, from the same origin, one more object is being projected with different velocity and different angle, but the angle remains complementary of this one, like this. So for this one, angle is what? 90 degree minus of theta. Okay, and it is being projected with initial velocity u2. So can I say that u1 and u2 are not equal? From this figure, can I say that u1 and u2 are not equal? Second thing, range of 1 is not equal to range of 2. Are yes or no? But one thing is same, that is what? Hmax of 1 is equal to what? Hmax of 2. Can I write like this? Both are equal. Okay. So whenever Hmax of two bodies are equal and they are being projected with one angle theta and the other is what? 90 degree minus of theta, again it should be what? Complementary angle. Okay, one is projected with theta and other is being projected with what? 90 minus of theta. That means let's say one is being projected with 40 degree, other is being projected with obviously 50 degree. Yes or no? 90 minus of 40, 50 na. So their Hmax, if their Hmax are equal, then you will be getting time of flights are equal. So T1 and T2 will remain equal. So this is your T1, consider, and this is your what? T2. The time taken of the flight T1 and the time taken by the flight T2, object T2 will be always equal. I got my point? Draw and write down. Okay, shall I? Now, next type of examples. Consider range is given and Hmax is given. So this is the Hmax and Hmax is given, let's say given, let's say 45 degree. No, angle is not given. Angle is also not given. We don't know the angle. So Hmax is given, let's say 20 meters. And range is given 80 meter. Okay. Hmax is what? 80 meters and Hmax is what? 20 meter and range is what? 80 meter. Question is find u. Find u. Okay. First try the angle, then find what? Range. Sorry, u. Okay, shall I? How many of you tried the answer? Not getting? Okay. Shall I? Acha, what is our general equation of Hmax? Hmax can be written as what? u square sine square theta upon 2g. Yes or no? Or yes or no? Similarly, range can be written as 2u sine theta u cos theta upon g. Are yes or no? We don't have what? Neither we have u, neither we have what? Theta. Yes or no? That means we can eliminate something. Okay. So consider this as your equation 1, this as your equation 2. Let us compare these two. So Hmax upon range. Hmax upon what? Range. Can I write these two equations, that is u sine of theta into u sine of theta upon 2g whole divided by 2u sine theta u cos theta upon what? G. Can I write like this? Or yes or no? Can I cancel this g and g? Similarly, can I cancel this u sine theta and this u sine theta? Can I cancel this u and can I cancel this u? Or yes or no? Then can I say that Hmax upon range, this is can be written as, can I write directly short h by r? H by r is nothing but this one is sine theta, this one is cos theta. Sine theta by cos theta, this 2 goes over here. That means, can I say 1 upon 4 tan theta? Are yes or no? Now, can I also say this as h upon r is nothing but tan theta upon 4? Are you got my point? Okay, now substituting the value, you will get what? Answer. Substitute and tell me the answer. Okay, shall I now? So from here we can calculate the theta na. So what is your h? That is 20. This is what? 80. So 1 upon 4 get cancelled. Theta is equals to tan inverse of 1. Tan inverse of 1 is nothing but 45 degree. Yes, how many of you got the answer? Tan theta is equals to what? 45 degree. Again, by seeing this angle. Previously, just now what we have learned, whenever the theta is what? 45 degree, if range is 1 meter, your answer of, if range is, height is what? 1 meter, then the answer of range will be 4 times, na? So, see the height. Height is how much? 20. Height is how much? 20. Range is how much? 80. Definitely our theta, we got what? 45 degree. Are yes or no? If the values are different, you have to do in this way. I got my point. First thing, you have to eliminate what? U. Then we can find what? Theta. Once we can find theta, we can substitute in any equation, either in this equation or either in this equation to calculate what? U. Let us substitute in Hmax. So by substituting in Hmax value is how much? 20. I am substituting this theta in Hmax. Okay. So 20 is equals to u square, we don't know, sine of 45 degree. Sine of 45 degree, root 2. Root 2 is square, 1 upon root 2, 1 upon root 2. That means into 1 upon 2 divided by what? 2g, that is 2 into 10. Can I? So can I say that this 20 and this 20, 40 into this 20, 80 is square. So u square is equals to 80, or u is equals to under the root of 80. Yes, sorry. Now this becomes what? 10, whatever it may be. Calculate and tell me the answer. Okay, shall I now? Next part. If range is not equal. Just now we have done 20 and 80 meter, na? Or yes or no? Consider they haven't given anything. And this is your range and this is your Hmax and this is your range. If they just provided you like if range is n times of height, then what to do? Substituting the equation. Substitute r value and h equation. What is our r formula? U sine theta, u cos theta into 2 upon g. Similarly, Hmax value is nothing but u sine theta into u sine theta upon 2g. Yes or no? Dividing these two equations. Dividing these two equation, again this u sin theta cancel, u get cancel, g get cancel, g get cancel, and what r is n times of this h na. So all you need to multiply this by r is equals to nh. Are yes or no? Or can I also write this r upon h is equals to n? Are yes or no? That means all you need to multiply this by what? N. If I multiplied this by n, then again equation of r upon Hmax is nothing but what? Over here you need to multiply by n na. So multiplying this by n, that's it. Simple question. So again you will be getting what? This 2 and this 2 multiplied by 4, and again what? This goes in the numerator, again becomes tan theta. Again becomes what? Tan theta. Then if I solve this, this becomes n, this becomes 4, that is sin theta by cos theta, that is tan theta. Then the equation can be written as tan theta is nothing but 4 upon n. Are yes or no? Substitute. If both are equal, these two get cancelled and left out is 1 na. Already given in the question, r is nothing but nh. So these two get cancelled, left out is 1, and this n can be multiplied over there. So 4 goes over here, n goes over here, and 4 goes to the numerator. So 4 upon n. Or you want to write theta. Theta is nothing but tan inverse of 4 upon n. We can generalize this. If theta is 20 times, substitute this, if range is 10 times, substitute 10 times. If height is, height is 1/4 times, you all need to substitute 1/4 time. Whatever the given quantities are, we can find better. Okay? Okay. Shall I now? Next example. Example number, whatever it may be. Now listen to me. Two objects thrown with same velocity but different angle. Okay, with what? Different angle. So can I say that let's say 100 meter per second. So one object 1 projected with what? 100 meter per second. This is your object A. Let's say with angle of 15 degree. With what? 15 degree. Similarly, one more object is being projected, and this object is also projected with 100 meter per second. That is your object number B. Both are initially projected with what? Same. So U is what? Same. Okay, that means can I say U1 is equals to U2? Second thing, point of projection is also same na. So point of projection is also same. Yes? Okay. Why I am writing means I derived one formula for you at the end without wasting the time. So whenever the point of projection is same, initial velocities are same, angles are different, then this is not only applicable for me to student to mug up their final formula. Okay, but JEE students must and should follow the mathematical part. Okay, they can provide you different initial velocities, but they will, don't worry, they will provide you the what? Same point of projection. They will provide definitely different thetas. Now consider this is 15 degree and the other is being projected with what? This one is 45 degree. Okay, now question is find out the time period. Find out the time period. So what is happening here? First 45 degree object is projected. That means B is projected first. So which one is projected first? B is projected what? First. Then A is projected. A is projected what? Second. Okay. Now, if A is being projected, the parabolic path of A will be like this. Okay. Then after some time, B is being projected. So T is projected at T is equals to what? 0 seconds. Object B is projected at what? T is equals to 0 seconds, and object A is being projected after some time, let's say T seconds. So T2 is being projected after some time t seconds. I got my point. So can I say that the time difference, that is t1 minus of t2, all you need to find this. You have to find what? The time difference. But the condition is also given. These two objects is being projected in such a way that in some way like this, they collided here. They got collided. If they are colliding, find out the time difference. I got the question. One more time. Two bodies, A and B. B is being projected first. Okay, initially B is being projected first with what? 100 meter per second or u meter per second. If you want to calculate the generalization, you can calculate with general values. So B is being projected at t is equals to 0 second with initial velocity 100 meter per second with an angle theta of 45 degree. After some time, A is being projected, both are being projected. After some time, with the same velocity 100 meter per second, but the angle is 15 meter per second, given that both are colliding at a point. So can I say that this is your xy? Yes or no? This is your xy. They are colliding here. All you need to find what will be the time difference of body 1 and body 2 thrown. Okay. So all you need to find delta t, that is t1 minus of t2. I got my point. Okay. Now, if I want to write the coordinates of xa, that means xa can, how much xa have been traveled, then can I represent over here for this body A and body B, this x value will be same, sorry, y value will be same. Similarly, body A and body B will be having a common time period, common coordinate, then and then only it will collide. So if I want to write the coordinate of xa, who is launched first, xb is launched first, then u, can I write cos theta 1, let's say theta 1 is 45 degree. So this is your theta 1 and consider this is your theta 2. So theta 1 and it taken a time period to reach that xb. Similarly, can I write xa is also equal to, with the same velocity with different angle, it will have different time. Yes or no? So two objects are being colliding at that coordinate. So can I say that this xa and xb both will be equal? Both will be having the same common coordinate. Yes or no? Similarly, in ya or yb can be written as u sin theta 1. अरे बोलो रे आगे t1 minus of half of gt1 square. Can I? Similarly, for ya, can I write this as u sine of theta 2 t2 minus of half of gt square? Are yes or no? But neither you have any value. Whatever the values are there, you can substitute here. But one thing you can eliminate, that is what common thing. What? U. So to eliminate u, can I use these equations? Consider this as your equation number 1 and equation number 2. Comparing, both are equal na? Both are equal. If I substitute over here, then the same equation can be written as xa is equal to xb. And xa is what? U cos theta 1 t1. And this can be written as u cos theta 2 t2. U get cancelled. Or yes or no? Or t1 can be written as cos theta 2 t2 upon cos theta 1. Okay. Substitute this in this equation. Why? Because ya and yb are also equal na. Ya is equals to yb. Write these two equations here. Substitute the value of t1 in this one. Okay. Then calculate the mathematical part. You will be getting a final equation, that is what? Delta t is nothing but 2u upon g sine of theta 1 minus of theta 2 divided by 2 whole divided by cos of theta 1 plus of theta 2 divided by 2. Okay, substitute your values, substitute the values in this equation. these values, substitute over there, you will get what? Final answer. Now one more thing, students of the NEET, just mug up this formula, okay? And you guys, especially the mathematics candidates, don't mug up this. Why? Because they can provide you different velocities, okay? And for NEET they won't provide this much mathematical part. All you need to mug up this: if two objects are being projected with same velocity from the same time, this equation is only applicable when point of projection should be same. Okay, point of projection should be same. Initial velocities of both bodies should be same. I got my point? And they are colliding. First body, second body, whatever they have thrown, just substitute in this, tell the answer. Okay.